Hi everyone, it's Dr. Tausman coming to you with the lecture after the second test. I've got the agenda right in front of me, so hopefully you do as well. And we'll go through some examples here of the situation at hand, and hopefully you can come up with a good outline and then get to the homework questions towards the end of this agenda. The place I wanted to start off was actually with a new type of statistic. Wanted to start it off with what was actually on the last test, and even before that. If you remember, we've done a few different statistics obviously this semester. The first one that we really had that you could use quite often was the idea of a t-test. And hopefully you remember a t-test, you have one independent variable and two levels. Most often it's an independent sample design where people are tested only one time, and you have one independent variable and two levels, and then you have a dependent variable that you measure as well on a continuous scale. Then we kind of moved up on the scale, and we got into, before the test, this idea of a one-factor ANOVA. And we said if you have two levels of one IV, you could still do a t-test or an ANOVA, but the advantage of a one-factor ANOVA was you could actually have more than two levels of an independent variable. Still one independent variable, but I think we had different types of lists, different examples for that, or different post-event wording. I think the question was brought up where it was smashed, it was bumped and made contact. Still one independent variable, which is the type of wording, three levels there, and then of course you get a significant difference. You don't know exactly where it is. You don't want to do t-tests after that, because then you'll tend to have a family-wise type 1 error, an alpha level that's too high. But instead of doing that, you do these post hoc tests, so like the Tukey's test, and there's some other ones as well to see which groups are different. Well, tonight I wanted to bring to you a new example of a situation. Let's say that you're just doing a study and you want to look at how gender and a drug might actually impact pain perception. So you think you got this new drug and you think it might actually help with pain perception, but you think it might affect gender differently. So you give all sorts of people the drug or the no drug, and if you look at the matrix for A, you can see in this case we actually have two independent variables. One variable you would call gender, and usually the two levels of gender are male and female, unless there's special circumstances. We won't go into that. The other variable here might be the condition or the group, and that one might be the drug condition. One is no drug, none. The other one is with the drug. So you might actually have two independent variables. You might measure pain. Got a slightly new term for you as well. If you measure pain on a 10-point scale, one of the terms we often use when you measure a dependent variable is called an operational definition. An operational definition is a mathematical way to define a variable. So if you define pain by a 1 to 10 scale with a number like 10 meaning more pain, then that's an operational definition. So could you do a one-factor ANOVA on this or a t-test? Well, not really. You've got two separate categorical variables, the condition of the drug with none and drug, and then gender with the two levels there. So this is actually classified as a 2-by-2 design, and of course the one dependent variable. So a two-factor ANOVA basically means two independent variables. Now let's take situation B here. Let's say you wanted to look at people's attitudes about the Affordable Health Care Act. And let's say you thought that that might depend on both race and socioeconomic status. So let's say you designed a study and you decided to get people who were white, African American, and Hispanic, and then you also looked at people who were in those three racial groups but who were making an income that was either classified as low, medium, or high. That would be a situation, once again, with two variables. You wouldn't actually call them truly independent variables, because a true independent variable is often manipulated by the researcher, and there's nothing really being manipulated here. We would call race and SES quasi, Q-U-A-S-I, quasi-independent variables, because they're not really manipulated, but we have three different groups of race and three different groups of SES. They're not really manipulated, though, so this would be a 3 by 3 design. So with a two-factor ANOVA, we can have more than one independent variable. We've got the first 2 by 2 example with gender by drug. Then the second one is an example of affordable healthcare attitudes, maybe a 100-point scale. Race and SES, that would be a 3 by 3 design. So hopefully that makes good sense to you. I'm going to close the first recording off on this one because the next one we're going to go into some detail with. Thanks. Bye.